Hey, it's Mr. Redstone, and in this video we're going to be graphing some lines in slope-intercept form. That is y equals mx plus b. Now we call it slope-intercept form because it tells us the slope and the y-intercept. This letter b tells us where the line will cross the y-axis. This letter m, that is the slope. So in this first example, the first thing we need to do is ask ourselves, is it in slope-intercept form? And it is. That means we can pick off b, the y-intercept. So we are going to plot where the line crosses the y-axis. The slope is 3 over 4. Now what the slope is telling you is the change in y divided by the change in x. And if we understand what that means, we can plot all the points we want. The change in x was 4. The change in y was 3. So you see how we can plot some more points by using the slope. So if I were to connect these as straight as I can, we would get a line that goes up to the right, much like this. Next example, we are going to graph y equals negative 2/5 x plus 1. So again, it's in slope-intercept form, so I can readily pick off the y-intercept of 1, and I'm going to plot that. The slope is negative 2/5. And students will sometimes say, is the negative on top or the bottom? And I'm going to tell you it's the same. And to prove it, I'm going to show it to you both ways. Negative 2/5 or 2 over negative 5. So if the slope was negative 2/5, that means every time that x increased by 5, y is going to decrease by 2. So we go right 5, down 2. Now to illustrate what a slope of 2 over negative 5 would look like, I'm going to change the color of my pen. That slope would tell you that every time x decreased by 5, or we go to the left, y is going to increase by 2. As you can see, we end up with that same line. It's sloping down toward the right with a slope of negative 2/5. Next example. This time, to make it a little bit more difficult, it's not in slope-intercept form. So if we want to graph this, we're going to have to start by solving for y. Now, in a previous video, I showed you how to do that. But we're going to subtract 2x from each side. So y is going to equal negative 2x's plus 7. We now know what the y-intercept is, 7. And the slope is negative 2. But I'm going to write that as a fraction, negative 2 over 1. That means every time x increases by 1, y is decreasing by 2. And I do it a few more times. The more dots you make, the more accurate your line is going to be. So I connect them with a straight line, and there's the line, y equals negative 2x plus 7. Sounds like there's a fire truck behind me today. So last example, negative 3x subtract y is equal to 1. Again, we're going to have to solve for y, and we do that by adding 3x to each side. So we've got negative y equals 3x plus 1. We're not done yet, because I don't care what negative y is. I want to know what is positive y. So after you've been doing these for a few days, you could probably do this step in your head. But I'm going to write it as negative 1y equals 3x plus 1, and then divide everything by negative 1. Essentially what that does is change all of the signs in this equation. So I'll get negative 3x subtract 1. I begin by plotting the y-intercept of negative 1, and the slope is negative 3 over 1, which means every time x increases by 1, y decreases by 3. And I like to do this a couple of times. Again, it just gets me a straighter line. I connect them, and I am done. So thank you very much for watching, and I'll see you on the next one.